Hello, it's me, and I'm here to demonstrate another part of the 3x3x5 collection, and it's this tricube, where you have an interesting configuration, a little different from the rest. You have the cross pieces, the cross layers that kind of each go at right angles with each other, forming this triad of layers over here. Now, if you got this, more than likely you got the rest of the series here. More than likely you have them kind of hanging out, if not the rest of the series, then a good number of it, as we kind of put them in the backdrop over here. And of course there's more. But in any case, the question that I've had people ask is, well, if you buy one, do you need to buy them all? Do you need to buy the entire series? Which one of them is more indicative of the greatest challenge? Which one is more, has enough different characteristics to mandate that? Well, the fun thing about this series is that everyone has specific types of characteristics that make it unique from the rest. So the question is, with this puzzle, how is it different from, say, the ones that we've seen before? The L cube, the T cube, the X cube, the I cube. Does this tricube offer anything different in terms of the challenge? And the answer is, well, yeah, it does, actually. There's something that happens with this configuration that you don't get with the other configurations, because you can solve it like the centers of a 5x5 supercube, or you can solve it like the top and the bottom of a 3x3x5. So when you see that the cross extension, now I say cross because if you take a look at the classic cross cube here, this is really just a 3x3 with a center that moves like a cross cube with little extensions glued onto that. When you take a look at how these are solved, if they're next to each other, then they're solved as the last two layers of a 5x5 supercube, just solving the centers there. If you find that they're at opposite angles to each other, like these two, or, I don't know, these two, we'll be coming back to that one, or these two, then why don't we just solve them the way we would do a 3x3x5 using cuboid strategy between the top and the bottom. Of course, you have the possibility of having the I-cube formation, where you have this top, which is really just kind of an isolated 3x3 amongst, or isolated 3x3x1 amongst a base 3x3 puzzle. So how do we go about this? Well, it has I-cube type scenarios on each side, where it's sort of off-center, but it also has the ability to solve at right angles with each other too. But let's see what happens as we try to solve this. Let's clear the way over here so there's no distractors. And we're going to solve it based on the beginner's method of a 3x3. And I'm going to actually use this to demonstrate, just in case you don't have the other puzzles in the series. Although I think it's safe to assume if you've got this, you probably have the others as well. Now, just to demonstrate the movement of these puzzles, it's really quite good. The movement of this puzzle is actually very smooth, and it's really a pleasure to just kind of move around. And I'm going to continue to just kind of mix this up. What I like to do is mix the cross areas up first. Just kind of take them all out of alignment here. And I'm going to show you something kind of interesting about this puzzle. Just to show that these actually all have cross areas here. I just move this over here. That even though you have certain base 3x3 components to it, these all can potentially act as a cross layer. The center can actually turn as a cross. And just to show you what I mean, if I were to say, put these over here, put these over here, this can actually turn like a cross cube. So the center, even though it doesn't look like it's bandaged, can actually function as that. And all the other sides can do that too. So here's a green side, put this in, and now this guy can turn. So there's a variety of various scrambles that can happen. So we're going to keep going on with the scramble with this and see what kind of a mess we can make. Abracadabra. Okay, and let's kind of correlate this with the mixing up of an actual 3x3. Okay, so we're going to start off the way that I do with all the cross puzzles here. These are cuboid variations where the cross area is, instead of being at the top and the bottom, is at various places at the side. So what I'm going to do first is solve the base 3x3. By solving the base 3x3, we get it back to the native shape, and then we solve the other cross extension layers as a 5x5 supercube. So let's see what happens as you go through this, and if you're considering buying this, let's go ahead and see what kind of differences happen as we solve this. So the first step is, let's go ahead and get centers. We can start off with one of the base centers of the puzzle. We'll do the yellow one. So when doing this, and we'll correlate it with, I guess, the yellow side over here, we get the cross, and the cross just means putting the edges in. So here's the orange edge, yellow and blue. Move it into configuration here. Yellow and green. Move this up, move this up. Now I'm going through this for a specific reason, and if you pay close attention, you're going to understand why in a little bit. So we've got the cross here, and then we simply put in the corners. Corners are just a matter of, once again, placement. Turn it here, and like so. These are RIDIRD moves, and again I'm just using standard 3x3 techniques. Turn, 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 and I assume you know how to do this part. If not, let me know, I can point you in the direction. Turn, turn, turn. So the characteristics of this are you have all the edges and corners in, and it correlates with the center over here. So we're going to do that with this guy too. Now taking a look, we have the yellow side here. Now here's a yellow, but where does it go? Well, this yellow has right next to it a bandaged side here. This is a bandaged cross extension over here. So this is going to juxtapose between the center here and one of the cross sides. Well, which one? It could be this one, or it could be this one, which means that this piece has equivalency. I could have it here so that I have this yellow edge right next to this cross extension layer, or I could put it here. It doesn't really matter. So it can be here or it can be here. So we'll just keep it there for now. We've got this. This one has specificity because it's going to be yellow and red. So I'm going to place this between the yellow and red side over here. So far pretty straightforward stuff. Move this where it needs to be here and move it up. And we can see that this one is already in, green to correlate with the screen side, and yellow to correlate with this. So we move from here, we've got a yellow with a cross extension layer, and that's going to fit very nicely here because, well, the yellow belongs next to here and the cross extension layer here. So move it up, and we have the cross, correlates with this. The cross is basically an edge that correlates with the top center color, and also the centers that's immediately adjacent to it. So red, cross layer, cross layer. So corners, now this is a yellow and red, so this belongs by yellow and red. Well, actually it's a yellow that comes up here, but a red and a cross layer. So let's find the red center, which is here. So where does this go? Well, it belongs next to the one where the red and the cross extension layer goes, which is here. So this belongs here and not here, where it's got to be by the green center. So what I'm going to do is move this down, bring it in, and move it up. So the red is where it needs to be, and the cross layer is where it needs to be also. Well, here's a standard one that looks like, well, one of these pieces. It's got 3 to correlate with these 3 centers. So I'm just going to move it down and move it in. So we're doing well. Now I've got this one. So this is a yellow, and it's got attached to it 2 cross extensions, which means that this belongs between 2 extension layers. So we've got an extension layer here and here, so this belongs over here. So we're going to move it down. So unlike the edges in this puzzle, the corners have specific places where they go, because this is the only one that can do that. So you can see this correlates with this cross extension layer, as does this. So now we've got this one. This is the yellow and green, which correlates with this green and yellow here. So take it down, move it across, and up. So we have our first layer, much like we had it over here. We see this is correlated, these two are fine, and these two are fine. Understand, once again, the corners had specific places to go. These 2 edges can flip-flop with each other. Middle layer, well, this has a pretty simple algorithm associated with it. So this is going to come down to here with a left-sided version of the algorithm. UI, LI, UL, UF, UI, FI. And there it is. And once again, this one goes to the right side. UR, UI, RI, Fi, Ui, F, well, something like that. Anyway, I've been through that algorithm before. And finally, this is going to come down here, turn, 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 and turn. Okay, doing exactly the same thing here. Turn it upside down as we're getting our base 3 by 3. So what goes where? Well, each of these edges had a very specific place to go. But as you've seen in previous 3 by 3 by 5 variants, some of these edges can be flipped upside down and you wouldn't know and you wouldn't care. But let's see what we've got. Here we have a red edge with a little cross extension over here. So where does this belong? Well, this finds a nice home by this cross extension center. This can flip down to here, so this can go here. Can it go anywhere else? Nope, it pretty much has no choice. It needs to go here. So we're going to do the left-sided version of the algorithm. Ui, Li, U, L, U, F, Ui, Fi. So that's what I mean about this fitting here with the cross extension portion fitting with this cross extension center over here. This obviously doesn't belong here, but what about this? Well, here's a red with a cross extension. Now here's what's interesting. This could go here too. So it's either or. I put this one in, but I could put this one in. So I have two edges that can go either or, and that's because these two are equivalent to each other. I can flip that because this is a cross extension layer, and this is a cross extension layer too. Again, by cross extension layer, I mean anything that's attached to the 3 by 3. It really came from a cross cube and became an extension. So which one should it be at the moment? It doesn't matter. It could be either or because as long as it's part of the base 3 by 3, I can switch those. So I'm going to keep that there for now. Let's see what else. Well, here's a green. It belongs with a green center here. Doesn't go, well, where can it go? It can go here because this cross extension edge can fit with this cross extension center, or it can go, well, it can't go here because this is not a cross extension area, this is just the red center. So I'm going to move this to here. Same algorithm. So far, I'm not really rocking your world with this. There's no real difference between this and the 3 by 3 so far. But let's see where things go. And now what? Well, here's a green center. We can use some more greens perhaps. Put this here, and where does it go? Well, actually, it could be either one of these. I already put one in here. Could have been this, but not so much now. How about here? Well, what goes here, notice, is there's not a base color that goes here. This one obviously doesn't belong. But it's got to be something that has two cross extensions attached to it. So it's an edge without the center 3 by 3 that you can see. So here's such an edge. This has two cross extensions. One can fit with this center, the other can fit with this center. And the thing is there's two that can do that. There's also this one. Which one is it? It doesn't matter. Which orientation is it? It still doesn't matter. I can flip it in from here, or I can flip it in from here. So I've got two pieces, two edges that can come into this space, each with two potential orientations, which makes this part quite easy. So I'm going to go ahead and put this in with the same algorithm. Turn, 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 and turn. So now that's in. We did bump this out. This is the only classic edge piece, or actually this is the only classic edge piece that we could see. This comes into here to be taken down with the green to this green center. Turn, 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 and there you go. Okay, so the second layer is now solved. That's now where it needs to be. So the last layer, well, basically it's a matter of permuting and then orienting, or orienting and permuting. So the first thing that I want to do is I want to rotate all the white ones up. All the edges of the color of the center have to be rotated up. So what this algorithm is going to do is it's going to cause this piece to slide over here and flip, this piece to just slide over here but not flip, and this to jump over here and also flip. So when I see this L formation, if I do the algorithm once, this will end up over here and flipped right. This will slide over here and still be flipped wrong, and this will flip over here and be flipped wrong, giving me a line. So that's going to be F, R, U, R, I, U, I, F, I. There's that line. Do it again. This will flip. This will slide, but not flip, as it doesn't need to. And this will flip, so I'll get my cross appropriately. F, R, U, R, I, U, I, F, I. So there you have it. Okay, now that I have that, I have to orient the edges appropriately. So I move and I see that, the next step is to orient the puzzle, orient the cube. After orienting the cube, we then look to see if there's any corners that are in. And without getting into too much detail, because I've gone through this a couple of times, you look to see, well, here's a corner that makes sense over here. Once the corners are oriented, once the corners are where they need to be, see if you can see that this one is correct and this one is correct. You then do RIDIRD until you get everything up. RIDIRD, RIDIRD, DIRD, RIDIRD. Move this across, and same thing. This is just kind of a review. So just by way of demonstration. Okay. So same thing with this. What I'm going to do is I'm going to solve the last layer of this puzzle. So the first thing that I want to do is I want to orient edges correctly. Well, it's pretty easy because there's only two edges that need any orientation when you think about it. Because I've got two edges that have cross places attached to it, this one and this one. These don't have a specific orientation. I don't have to turn this upside down or right side up because it's always the same. In this particular puzzle, there's two edges that do have a specific orientation. This one and this one. So you can see this red has to be standing up so that it's with this red center, and so does this green. So really it's just a matter of orienting just these two. So how am I going to do that? So really what I'm looking to do is I'm looking just to get every one of these cross sections facing up, none of them facing down like this. Now this almost looks like a quasi-parity, but it really isn't because these guys can flip. So what I'm doing is I'm assuming that this is flipped correctly and this is flipped correctly. So it's kind of like an L formation over here. So we're going to hold it over here and do F, R, U, R, I, U, I, F, I. We'll just move that out of the way there. All right, so what we have now is this is oriented correctly, and this is not quite oriented correctly yet. So I'm going to treat this like this were the line. This is correct, and this is correct. And I'm going to assume this is not correct, and this is not correct. This one is kind of arbitrary, but at least it works. Because this can be either way. So I'm arbitrarily defining it. F, R, U, R, I, U, I, F, I. So as long as I have these guys up, we're okay. All right, now it's a matter of lining these up. I'm putting this over here. Now I'm going to do the algorithm until the red edge is over here. Right now it's over here. But by doing the RU, RIU, R2, URI, I can keep doing that until this finds its way here, and that's all I need to do. RU, RIU, R2U, RI. And as you can see, these two are by the centers that they need to be, and these edges here are by the centers that they need to be. Cross area, you have these two in, and same thing over here. Next, we do corners. Now it's a question of finding what corner belongs where. Well, taking a look at this, this is the corner that has green and red. Well, this is green and cross. This needs to actually be over here, so this is wrong. This one is just red with two crosses, which means this is not supposed to be here because this is where this one belongs to. This belongs, say, over here. Because over here you have red with two cross areas, so this belongs here. This is three cross areas, so this is the corner that juxtaposes between three cross layers. So this belongs over here. So this is wrong because it belongs here. Since this has three cross extensions, this has to be the corner between the three cross layers. This is the green with two cross layers, and that belongs here, which is green with two cross layers. So when you come across a situation where none of them are in, we'll just arbitrarily do the algorithm to permute them around until we get one in. U, R, U, I, L, I, U, R, I, U, I, L. Now, when solving these puzzles, it is important to understand the law of cubes. And I probably should take a moment to demonstrate what I mean by that, because that'll tell you when some kind of a parity may or may not be happening. Basically what it means is that I can't do an odd number of swaps. I can't just swap two things. So in this puzzle, the true measure that the 3x3 is set up correctly is you have one that's in, or all that's in, or none that's in, but you can never have two that's in, whether it's two edges or two corners, because that means that you've broken the law of cubes. You have to just swap one, and that's not going to work. So that's how to tell when something's not quite right. So let's take a look at this. Well, this is where it needs to be. It's a green surrounded by two cross areas, which is this, so that's fine. And all I need to do is find if one is in, if another one is in, or another one is out, in which case, then I know that it's not correct. Well, here's the red one. This obviously doesn't belong here, so by all sense and purposes, that should be enough. I hold it over here, do that algorithm again, and permute them around. Except what you're going to come across is a little bit of a problem, because this is correct, this is not correct, this red and green doesn't belong here, it belongs here, right, by the red and green, so this is not correct. But take a look at this. This is correct. You can see it fitting nice and snugly between these cross areas. So we have what appears to be parity, because it appears that these both are in and these need to be flipped. And you can't have that. So what happened? Well, there's a couple of possibilities. There's a couple of thoughts as to how that happened. We've seen this happen in other cross puzzles as well, and it has to do with some of the equivocation. We may say that, well, this edge here that was placed in the middle, maybe that's got to be flipped around. Maybe that's got to be turned around. Well, I'll tell you that the solution is not that simple. So here's my question to you. Here's my challenge. In this particular puzzle, how did this happen? How did this particular configuration occur? Because once we know that, then we know how to fix it. Now, if you look closely at the video, I actually gave you a key hint as to why this apparent parity happens with this puzzle. Now, I'll tell you that it's not real parity, not the way that I look at things. But somewhere in this video, there is a hint as to why this happens, and it might be staring at you right now. So take a few minutes, decide what exactly it is, why this happened, and how we can maybe fix it.